Hey class, so in this lesson 24-1, we're going to keep it very simple. It's just going to be introduction to polynomials. So we've done this before. Um, it's nothing new. We're just going to look at some specific terms, something for you to recognize. Uh, and then I'll give you some work based on this, and you'll find it in the same folder. Again, just a reminder, make sure you're doing the work that you need to complete to pick up your grade. I'll be giving an update about grading and what grading is going to be. It's going to look like now that we know we're going to be doing this till till this end of the school year. So, but for sure, my advice as of now is this: if you have an F or a D or a grade you're not happy with, make sure you do the work. However, like I said, I'll address this later this week. Anyway, so polynomials, parts of a polynomial. So we've used this vocabulary a lot in class. So I just want to talk one example um, and then again, it's going to be a short video today. So we talked about what a term is. We talked about, polynomials, definition of a polynomial, and what coefficients and the constant term. So all this stuff, some of the stuff we have mentioned before. So the book gives a nice definition of what a coefficient is, what a constant term is, and degree of a term, degree of a polynomial, and standard form, descending order, leading coefficient, and all this stuff. So, and here's another example of, specific terms about polynomial. So a few things that I want to emphasize is one, a polynomial could be a single term or the sum of two or more terms with, this is the big, whole number powers. So it means that when we look at the powers, we have to look and make sure that they're whole numbers. If they're not whole numbers, guess what? It's not a polynomial. So if in case you're asking, oh, what's a whole number again? So whole numbers starts with a 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and it goes on. So that means that if I'm gonna have a polynomial, the powers have to be whole numbers. It could be 0, it could be 1, it could be 3, 4, 5, 6, 7, 100 up to 105, and so on. But it has to be whole numbers. So I just want to talk about degree of a term. So the degree of a term is this. Don't want to spend too much time on this because we don't really address it as much, but for sure, this is something that we do use a lot in higher math, especially in algebra 2, which you'll be doing, eventually. Degree of a polynomial is the greatest degree of any term. So again, what is a term? So terms are the what makes up a polynomial. So in this case, we have 1, 2, 3 terms. So this polynomial has 3 terms. In this one, notice that there's 1, 2, 3, 4. And notice the terms are divided, are broken or separated by either a plus or a minus. So this one has 4 terms. And notice this one, 1, 2, 3. This one also has 3 terms. And again, notice the powers. We don't see the power here, which is a 1. We don't see the power here, which is a 1. But for all of these, the powers are whole numbers. Again, we don't see a power is because it's a 1. So going back to degree of a polynomial, the greatest degree of any term. So notice that in this case right here, so I'm gonna let in green. In this one, the highest is this degree, which is 2. So that's why the degree is 2. And the constant term, so I'm gonna go back to right here. Constant term, we talked about this, is just the number by itself, a number that has no variable next to it. So in this case, the constant term it's the 7. Notice that this is the only number in this polynomial that has there's no variable next to it, there's no letter next to it. So here the constant term would be 7. So in this example right here, the degree of the polynomial, again, is the one with the highest power will be this one. So the degree would be 3. And again, the constant term would be the term that has no variables. So in this case is the 3. So the constant term is 3. And we said the degree of the polynomial is the degree of the polynomial is 3. Sorry, -3, the constant term. I forgot to incorporate the sign, -3. So notice that in the last polynomial, the constant term is 36. This is the number that is the term that has no letter next to it. And the highest power that we see is this one. So it means that this polynomial has a degree 2. So that's one terminology for polynomials. So here's another example. The degree of this polynomial is, so one at a time. The degree of the polynomial is going to be 5 because that's the highest power that we see. The constant term is -3. We see that this polynomial has 1, 2, 3, so 3 terms. And this is the newest one. What do we mean by leading coefficient? So here the leading coefficient is the number in front of the variable with the highest power. So one way to look at it is the number next to the variable with the highest power. So that's what leading coefficient is. So if you, my advice is to look at this section of the book, again, 24-1, and then look at the tables for examples. Some polynomials have very specific names. If it's only one term, we call that a monomial. If it has 2 terms, we call that binomial. If it has 3 terms, we call that trinomial. But after that, we just call it polynomial. So again, a lot of vocabulary here. And this is all I want to talk about. I gave you some work on Alex from assignment number 9 from Alex on polynomials. So again, if you don't know how to solve it, redo the example, work on it, try it, and where you have multiple attempts to do it. So please do the work that goes with this lesson. And again, I'll be available on Friday from 9 to 10 through Zoom. I'll send the link out there for you to have it in case you have questions or any concerns. All right, so guys, take care and stay safe.